not just last lecture, but this is important concept, right? You treat this as a review for the next midterm. How do I find the pole of any circuit without solving KCL and KVL? That is what we learned in the last 2 lectures. We start from the input signal, go through the signal path, right? We ground all the independent source, including the input. And naturally, we ground all the constant voltage source, which are independent, but also because it is AC signal analysis. We identify the node. I see I have one node here, another node here. And then all I need to do is to stand on this node and then try to ask myself, if I want to go to ground, what resistors will I encounter? What capacitor will I encounter? And when we treat this, when we look at resistor, you completely ignore the capacitor as if you can erase it. When you try to look at the capacitance, you ignore the resistors, you can erase it. Okay? And that was the first mistake I made, right? 2 weeks ago, about when there's no resistor. I actually still remove it. I cannot ground it. Remember that one? Right? But anyway, what is the pole of the first node based on this? I see that pole 1 equals to the equivalent resistor and capacitor. And the equivalent resistor going to the ground is Rs. The equivalent resistance, is that right? What is the equivalent resistance going to the ground? Rs and what? 1 over what? You're right, 1 over what? So here I have a path going to the ground, right? I got Rs. How about the other path? 1 over Gm, right? So it's Rs parallel 1 over Gm, right? And then what is the capacitance brings me to the ground? I just stand here and I ignore all the resistor. What's the capacitance that will bring me to the ground? See, it's very trivial, but you just need to be very careful, right? I don't have the cheat sheet. I hope. Yeah, see, sorry. I don't have the cheat sheet. You might want to double check, but I think I'm correct. Okay, someone asked, how about RD? Do you remember why I don't put RD? Anyone remember? Yes, very good. So he answered himself. That is because the so-called input, the impedance looking up, how do we get it? We solve KCL and KVL. And this turned out to be the input impedance of a common gate amplifier without channel length modulation. It does not depend on RD. Again, looking into the source is not always 1 over Gm. It is only true when you ground the gate. You have a constant bias. And in that case, anything after the drain can be ignored. Unless I tell you that you cannot, you need to include channel length modulation. Right? Because with channel length modulation, the input impedance will be different. I think it is RD plus R0 divided by 1 plus GM R0. Okay, I think I'm right, but just in case I'm wrong, I will erase it because we have this in the previous lecture, right? So for those who did not listen to the video, won't get confused. Is that okay? Now, this is a very important question and very important concept. Are you okay with this? I really hope you don't make this mistake anymore. It's okay that you forgot what it is, but at least you know that I cannot just say it is 1 over Gm plus RD. Right? You can say, oh, I really forgot the equation. There's something fishy I need to check. That's more important than you memorizing the equation, right? As an engineer, the intuition and the awareness of the pitfall and make you a variable engineer, right? Because the marketing people, they just brag. They say we can do this, we can do that, give you a rosy picture and ask you to get the products to the market. But if you don't tell them this is wrong, your company's reputation will just be gone. Sometimes you need to stop those marketing manager. Okay. Okay, good. Now, this is one. And how about the second one? The second pole. Again, it is 1 over RC at the pole, at the second node, right? But now I'm standing here. So from here, what are the resistors that can bring me to the ground? Yeah, your finger is pointing up. RD. RD is one of them. What else? You just go around, right? I can go up. I can also go down. What is the resistance going down? Many different answers based on your assumption, but you should give me some valid answer. What's the resistance going down?
It should be the same as common source.
It should be the same as common source with degeneration. Very good. That is one answer. Another answer is that I said no channel length modulation, so it's infinity. I don't care, right? That is also another answer. Because common source with degeneration depends on R0, right? R0 now is infinity, so you make it infinity larger, it is still infinity. Okay, so yeah, so that is the answer I want to look for. I hope that you did not tell me it is R0 plus Rs. Right? Again, why it is R0? When you have a transistor, it is R0 only when the gate and the source are grounded. But now the source is not grounded, right? So you cannot say that. The worst thing you can say is just that, let me do KCL, KVL, right? The best thing is that I see that this is a common source with degeneration. I already have that in my cheat sheet. I know that it is R0 times Rs times GM, or the more lengthy equation. Okay? Now, because this is channel length with modulation, so let me just put infinity. No channel length with modulation. No channel length modulation. Then how about the capacitance again at this node that can bring me to ground? CL, right? Treat as a review. On Wednesday, I might not review much because I will talk about the speaker. I mean the output stage. Okay, for your lab. Good. So this skill, as long as you memorize what I told you, you should not make mistake, right? You might not be able to solve it, but you should not make mistake. The worst thing I want to see you tell me that I don't know how to solve it, instead of giving me something that like 1 over GM plus RD. Okay. Now, in order to use this one, we assume that the capacitor or resistor always has one terminal connected to ground. But this is not the case in all circuits. For example, in this case, although this is a triangle amplifier, it's just like this one. It just means that maybe I have many transistor, resistor, capacitor here. It's still an amplifier. But I do have a capacitor connecting from V into V out. It can be from any place at any places. Doesn't have to be V into V out. But both of the terminals are not connected to ground. Then in order to find this one, what did we do? We used the so-called Mueller theorem. Right? And what is a Mueller theorem? What is the Mueller theorem? It says that, well, if I just want to find the pole in this case, I can make an equivalent circuit. I break the capacitor into two. Each of them has one terminal connected to ground. That is the main point. Okay? You break it, if they don't have at least one terminal connected to ground, then you are not achieving any goal. So we break it, V in to CF. We become CF times a lumber to the ground. At the V out terminal, we still have connected to CF, but become CF times another lumber. And what is this number? This number is based on A0. Only in this case, if the V out equals to negative A0 V in, then we have this equation, 1 plus A0 and 1 plus 1 over A0. This is for the capacitance case. We actually derive the equation for a general impedance. Remember? For example, if I actually have something like this, look at this, it's A, not negative A0, right? So you need to look at what I give you carefully. If this is CF, right? I will be able to make this into something like this. Right? Remember this? But what is the value of this guy? Do you remember what it is based on the hint here? But we are talking about CF instead of capacitance, right? 1 minus A is correct, but I'm talking about impedance, not capacitance, right? So it should be what? Yeah, it should be CF divided by 1 plus A. Yeah, very good. So first of all, the trick is this is no longer negative A0, so this is 1 plus A. Second, this is C, right? This is impedance, right? Impedance is the inverse of the capacitance, right? When we derive it, we derive the impedance, and then we say the capacitance is the inverse of the impedance. That's why it is CF times 1 plus A0. So this is wrong. No one say this is 1 minus, yeah. Okay. Is this okay? And how about this one? What is this one? What's the output capacitance now? CF divided by 1 minus 1 over A. Okay. Any questions? I mean, you need to ask now, right? Instead after the midterm. Any questions? You will see this type of question for sure in the midterm. Yeah. 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 So if it is inductor, what is the impedance of inductor again? SL, yeah, or omega L, right? SL. So I just say Z of inductor divided by 1 minus A, and then Z of inductor is SL, so it's just L divided by 1 of 1 minus A. Right. Very good. Yeah, good question. Okay. I want to do